All right, we are back to talk about confidence intervals, and we have our helper again, Jansen. Hi, Jansen.
Hello.
Hello. All right, and we want to know something that Jansen might be interested in. So we are going to talk about his favorite cereal,
Cookie Crisp.
Cookie Crisp. All right, let's see the size of one of those Cookie Crisps. All right, so we have this tiny little Cookie Crisp, yes. And how many did you think were in a box?
180.
All right, 180, which he thought because he saw this number, 180, right on the side there. Yeah. So what we know is that there's a lot more. We're not going to tell you how many more, but there are a lot more Cookie Crisps in that box. So Jansen and I shop at the Dollar General. We like the DG, don't we? Yeah, we like the DG. Now we can't know how many Cookie Crisp are in every single box because we cannot buy every single box. But let's say we do know, because somebody did go and count all of them for us, that every box has this number of Cookie Crisps in it. What we want to know is how do we estimate that population mean? And so we are going to do that today. Let's imagine we just pick one box. Jansen, if you could pick one box from the shelf, which box would you pick? Put a circle around it with your marker. Pick any random box, just random. All right, that looks like a good one.
That's the most Cookie Crisp in it.
That's a lot of, yeah. No kidding. That's a good choice. It's the one with the most Cookie Crisp in it. I'm not surprised. Okay, we have to take a quick break. All right, we took a quick break to do our math, and we found the average of that one box is 739. So his sample mean is 739. And there is no variance in one box, so our standard deviation is 0. If we had to write what our original distribution looks like, what would we write, Jansen? We would write this, where our mean is 739 and our standard deviation is 0. So we did one box, but that isn't a very good estimate of a sample. So what we want to look at is maybe 10 boxes. All right, so Jansen, you can pick any 10 boxes, and it can include the box that you already used one time because we're putting it back. We are replacing it. So in just a second, I want you to just circle any 10 boxes, okay? Don't look at the numbers, just pick them completely at random. All right, we paused while you were picking out all of our numbers. What happened here with this one?
It went a little off
How come?
because it's.
No, how come you had, why did you not circle a real number? Because you what?
Have my eyes closed.
Your eyes closed? When I said pick at random, I didn't mean just put circles on at random. I meant you could pick numbers at random. But that's all right. We got it taken care of. So what we did was we listed all of the boxes that Jansen picked. So there are the 10. Here's our 10 random boxes that Jansen picked. I put them into Excel, and I did the equal average to get the sample mean. I did the equal average, which is 720.7, and then I did equals STDEV on Excel, and it gave me the standard deviation for all of these scores, which is 11.32. So make sure that you don't forget the things that we've already learned up until this point. So how do we write our original distribution? Just like we did last time. We put x approximates. Yep, you can put that up now. Our mean, 720.7, and our standard deviation, 11.32. So now we're going to use that, and we know our sample size is 10 to create our sampling distribution of the mean. All right, so we have our original distribution written here, 720.7 and 11.32, which was our sample mean and our sample standard deviation. But we want to look at the sampling distribution of the mean, and so we're going to turn that standard deviation into a standard error of the mean by taking the standard deviation and dividing it by our square root of our sample, and our n today is 10 because we used 10 boxes. So our standard error of the mean is 3.58. So now our sampling distribution is written as, how do we write our sampling distribution, Jansen? Like this. We have x with the bar over it, and we have our mean stayed the same because remember it's just an estimate for us, and our standard error of the mean is 3.58. Now we're going to use this distribution to write our confidence intervals. All right, so we have our sampling distribution of 720.7 and our SEM of 3.58. We're going to use this to find our confidence intervals. So our confidence interval, because our sample is only 10 and it's very low, we are going to use a t-score to create our confidence interval. Remember our t-tables?
Yeah.
Yeah, we remember our t-tables. So if we have a 95% confidence interval, we are looking for a 0.05 alpha. So if we look on our t-table under two tails and you find 0.05, and you look at the intersection with 9 because our n is 10, so you look at the intersection with 9, you get this t-score of 2.262. All right, so we take our 2.262 and we multiply it by our standard error of the mean to get our our margin of error. All right, so Jansen, let's see the math. What happens if we multiply 2.26 by 3.58? We get 8.09, exactly. All right, 8.09. So what we can do then is add 8.09 to our mean and subtract 8.09 from our mean. If we add 8.09 to our mean and subtract it from our mean, we get a confidence interval, a 95% confidence interval of 712.60 on the lower end. That's our error bound on the lower end, and our 728.79 on the top end. All right, Jansen, so you know your numbers pretty well, right?
Yeah.
Oh, your 700s, you're pretty good at them. If we were to look at all of the boxes in our population, so come look over here at all of these. You see this low number of 712? Are there any numbers lower than that?
Yes.
Yes.
A lot.
Lots of them. Are there any numbers higher than 728?
Yes.
Yes. So what we'll notice is that we'll have some boxes that don't fall in our confidence interval. Our confidence interval only says the mean falls within the confidence interval, not all of the boxes. So if we were to count all of those up that fall within the interval, Jansen and I will do that. Jansen and I calculated up all the numbers, so all we did was we count every score that fell between 712.6 and 728.79. Do you remember how many we got, Jansen?
11. 34.
11? We stopped at 11 up here. It was a lot to write. So at the very end, we wrote 34. All right, we got 34 numbers. We only got 34 numbers out of the 66 boxes because we used the standard error of the mean. If we had used the original standard deviation, the 11.32, and we multiplied that by our t-value, a lot of our scores would have fallen within that. Probably almost 100% of our scores would have fallen in that. But we use the standard error of the mean. So there are scores that are way above it, like 739, 738, 740. Those are a lot higher than our confidence interval. So we only have a small percentage, about 50% of scores, that are going to fall within that confidence interval. What a confidence interval tells us is how likely it is that our mean falls within that confidence interval. So we're going to explain that next. Jansen picked another 10 boxes. He did a great job doing it at random. He just picked the ones at the end that he could reach, which is fine. So here's what we have, a new sample of 10 boxes. When I put those into Excel, the mean becomes 722.2 and the standard deviation becomes 14.6 something. Our 14.6 something then becomes our standard error of the mean when we divide that by the square root of n, which is 10 again, so we get 4.63. And so then we have our new sampling distribution of the mean, which is 722.2, and 4.63 is our standard error of the mean. We multiply that standard error of the mean by 2.26, which is the same t-value that we used in the last one because we didn't change anything. 95% confidence interval, and still our degrees of freedom is 9. And we get 10.48. So now our confidence interval is 711.71 and 732.68. You'll notice that's different from our last confidence interval. That was 712 to 728. The confidence intervals change every time we get a new sample. What we would do then is, if we were in class together, we would all list our confidence intervals on the board. And then what we would do is look at every single confidence interval and see if we can find the population mean. Our population mean, if we look at all of these and put all of our population into Excel, and we look at the average of the entire group of numbers, all 66 boxes, our population mean comes out to be 720. So our 720 is what we are looking for. We look at our confidence intervals and say, yes, it's in this one. It was in the one before. 95% of our confidence intervals are going to contain the actual population mean, but there's always going to be one population, usually out of our 30 students, because it's 5%. 5% are going to pick a sample that is not representative of our population. Not on purpose, we do this on accident. It's by error. That's why our alpha is an estimate of our error, because we picked a sample that was not representative. 95% of the students are going to have a confidence interval that looks something like this, where 720 actually fits within that confidence interval. But 5% of the students are not going to get that confidence interval. This estimate of our population mean is not 100% accurate. When we use a t-value that corresponds to a 95% confidence interval, we are only going to say that only 95% of the time is our confidence interval going to actually hold the population mean.